Okay, so right now out on your desk, hopefully you have something to write with. You should have the handout from the sub and then have a calculator. So if you don't have your calculator, you're probably going to want to have that out as well. It will help you with some of the weird numbers we're going to run into here as we go through graphing today. Okay, so today we're still talking about graphing quadratics, but like I said yesterday, just like we can graph lines in multiple forms, we can also graph quadratics in multiple forms. So the form we're going to be looking at graphing today is y equals ax squared plus bx plus c. This is our standard form of graphing quadratics. Okay, we're going to have very similar properties and some very similar rules. We just don't have the nice, neat convenience of finding the vertex by using h comma k like we had yesterday. Okay, so some things we're going to know. We still have the case that if a is greater than 0 or if a is positive, the parabola is going to open up. Okay, if a is less than 0 or if a is negative, then we know the parabola is going to open down, right? Those are the same rules from yesterday, right? Positive numbers made it look this way. Negative numbers made it go upside down. Okay, the difference today is that line that chops in half, that h piece, right? X equals h, that axis of symmetry, has more pieces to it. So the axis of symmetry is now going to be x equals negative b over 2a. Right? This negative b over 2a is going to be the same idea as what we used to think of as h. Now, most of my students prefer to bump this negative up in the top and say it negative b over 2a. Make sure you're not putting that negative with both of them. Okay. Just like yesterday, right? The vertex is going to be the max or the min of the parabola, depending on which way it opens. Okay, and we'll find that vertex by using this negative b over 2a, right? If this is the same as our h, it should be the same thing as the beginning of our ordered pair. And to find our y value, we're going to have to plug it back in, right? We'll take whatever we get here and we'll plug it back into the original quadratic function. Okay, so let's say maybe we have y equals x squared plus 6x plus 12. Okay, if we want to find the vertex of this, we don't have the nice, neat step of just finding h and finding k. Now we have to do some work to find it. Just like with any trinomial, right, we can find a, b, and c. Okay, so we'll say that a is equal to 1 because there's a 1 in front of that x squared. B is equal to 6. C is equal to 12. So to find the x value, or the first coordinate in our ordered pair, we need to do negative b, which is now negative 6, over 2 times a, which is now 1. All right, so this will be negative 6 over 2, or negative 3. Okay, so if we're talking about our ordered pair for our vertex, we now know that our x value for our ordered pair is negative 3. To find our y value, we now need to take our x equals negative 3, and we need to plug it back into the original equation. Okay, so because there's 2 x's in this problem, we're going to have to plug in negative 3 in 2 separate places. Okay, so y is going to equal negative 3 squared. Just like with the quadratic formula, right, we need that negative 3 to be in parentheses, especially if you're using your calculator. All right, plus 6 times negative 3 plus 12, right? I took out the x and I put in negative 3's in its place. You could obviously go through and choose to do this all by hand and combine like terms. The other option, right, is you could put this in your calculator in one long piece. Make sure you're putting that negative 3 in parentheses. Okay, and we'll get out positive 3. So that tells us y equals positive 3. So this says that our vertex is negative 3 comma 3. just like yesterday, right, the vertex was sort of our starting point. It's going to be the most important point to be able to graph the rest of our quadratics today. Okay, the difference is that we don't have this nice, neat, you always go over one and up one, or you always go over one and down one. Now we sort of need to see what's happening with the quadratic by calculating some other carefully picked points. Okay, and we're going to do that with a table where we're always going to put the vertex in the very middle of our table. We want 5 points, just like we had yesterday. Okay, and the vertex is going to go in the middle. Okay, we said when we graph a quadratic, right, whatever happens on the right side of the axis of symmetry is the exact same process that we want to imitate on the left side. Okay, so to find the other points here that we want to use, we want to count an equal distance, okay, from this x value. Which means if we're going to count by ones, we need to go up 1 and we need to go down 1. Now, that doesn't mean you have to pick one. You could choose that you want to count by 43 and go up 43 and go down 43. Okay, you could choose to go up 1/2. You could choose to go down 1/2. But, right, those are going to be things that are just more complicated to graph and give us numbers that aren't super fun to work with. Okay, so it's way easier to sort of just decide you're going to add 1 and you're going to subtract 1. Now, if you're not good with negatives, you could pick up your calculator, okay, and you could do -3 plus 1 equals, and -3 minus 1 equals, okay, or if you're fine working with negatives, right, you could just mentally do that math. Now, you do not have to still count by one more here. You could decide to count in any pattern you want here. Okay, but again, just being simple and being easy, right? We're sort of going down by 1, so we'll get a -5 and a -1. Okay. Once we have picked these values here where we know we're increasing at the same pattern going up as we are going down, we now need to take each of these values and complete the table by plugging them into our original function rule, right? So our original function rule is up here, right? We have y equals x squared plus 6x plus 12. So we're going to have to plug in 4 more values for x. And this is where your calculator can be really handy. Okay, so if we plug in the -5, right, we're going to say parenthesis -5, close parenthesis, squared, plus 6 times -5, plus 12. Okay, so it should look like this when you have it typed into your calculator. And that gives us out 7. But now instead of retyping in the entire problem for a new one here, you can just press your cursor up, right, and use your right or left arrow to change the numbers into the new one. So now instead of having -5 in both of these places, we want -4. So I'm just going to move my cursor over that 5 and turn it into a 4. I'm going to do the same thing here, right? You have to make sure you get them both changed. And then just press enter and it will spit out the new number. We'll press up again. Now we're going to change it into a -2. That gives me out a 4. And then we're going to change it into a -1. Obviously, you could type it in each time separately. You should be getting out the same answers. Now, if you haven't sort of already noticed, if we look at this list here that we have of our y values, right, we have matching numbers here, and we have matching numbers here. That is not a coincidence. Right, we said that a parabola was symmetric around the vertex, right, around its axis of symmetry, which means to get that symmetric piece, these values need to match, and these values need to match. If those don't end up matching, okay, you need to do a couple things. You should go back and check that you calculated your negative b over 2a correctly. And also go back and check and make sure that you counted or you properly spaced over here. Okay, once we have a completed table, then we just have 5 ordered pairs, right? This is the ordered pair -5, 7, -4, 4, -3, 3, -2, 4, and -1, 7. Right? We could just take these 5 points and we will plot them on the coordinate plane, and that will then give us our parabola. Okay, so obviously a lot more work than what we were doing yesterday. Not necessarily difficult, but a lot of plugging and chugging to making sure we're getting those values in correctly. Okay, so let's flip our notes over. Sorry, mine's the second page, yours is on the back. And let's actually walk through what this looks like in a couple different problems before you try some on your own. So if we want to graph y equals x squared plus 4x plus 4, the first thing that we should recognize is that this is in standard form, right? We don't have those parentheses squared, so it's not what we were looking at yesterday. Okay, so the first thing we're going to need to do is calculate that value of negative b over 2a. And that's what's going to go in the center of our table, right? That's finding our vertex. Okay, so if we look up here, we know a is 1, b is 4, c is 4. So negative b over 2a will be -4, negative b, over 2 times a, which is 1. Okay, and so we will get -2 as the value to go in the center of our table. Okay, then we want to evenly space going up and going down. Okay, so since this isn't a fraction or anything, right, add 1 and subtract 1 is fine. Okay, so if we add 1, we'll get -1. If we subtract 1, we'll get -3. Now, if you still are frustrated or you still struggle with your negatives, you can do that exact same process we did in our calculator before. So you can take -3 minus 1 and -1 plus 1 if you need to help yourself find those other values. Okay, and to finish our table, we need to find all of these corresponding outputs. So we're going to take our original equation up here and start plugging in each of these. Okay, so parenthesis -4 squared. I have to have those parentheses. Plus 4 times -4 plus 4. Right, we hit equals, that gives us out 4. Apparently we had a lot of 4s on that one. Okay, next we'll plug in -3. So I'm just going to go up. I'm going to arrow up and change my 4s, my -4s, into -3s. That gives me a 1. Okay, now I'm going to change these into -2s. Get out of 0. Now, assuming I did everything correctly, I better get out of 1 here. Okay, but you don't want to just guess 1 because then you won't have anything to sort of check yourself. So let's plug it in and actually make sure that's what happens, since it doesn't take very long, which we did get out of 1. So that tells us we're on the right track. We're doing things properly. Now, when you go to plug in 0, right, we can't have a -0, but remember you have this delete button right here. Okay, and you can use it to delete out that negative. And just change that into a 0. Right, it makes sense that we got out of 4 because those should match. So now we're going to go over to our coordinate plane and we're just going to start plotting these points. So I'm going to plot the point -4, 4. Right, so 1, 2, 3, left 4, up 1, 2, 3, 4. -3, 1. -2, 0, -1, 1, and 0, 4. And here's our parabola. Now, this should make sense that it opens up because A was 1, so we know we're going the right direction. Okay, there's our final graph for that example. Now, this one works out nice and neat. The numbers are nice and clean and pretty, but that is not always the case. Sometimes we need to deal with some other things that come into play, and you'll definitely want your calculator to help you. The process is still the same. You just really need to rely on your calculator to sort of help you with some of the weird numbers to make your life a little bit easier. Okay, so if we look at this one, okay, A equals -1, B equals -3, C equals 3. Okay, so for our middle point, right, we're trying to do -B. So the negative of -3 is going to make this a +3, just like it did with the quadratic formula. All over 2 times -1. Okay, so now we want 3 divided by -2. You can choose to work with this as a fraction or a decimal. I know I always say fractions are our friends. Okay, but in terms of plotting points, my students are usually more comfortable with the decimal format. Now, you can still decide to add 1 and subtract 1. That's a choice. Okay, but honestly, if we add 1 and we subtract 1, we're gonna continue to work with a decimal all the way through. Okay, there's no way of avoiding the fact that this is a decimal. We can't change that about this specific vertex, but we can choose wisely as to what we choose to add and subtract that will help us get rid of that decimal. Okay, so we could choose to add and subtract 0.5. I tend to think that makes it a little bit too close together on the graph. There would be nothing wrong if you did that. I just think it's a little bit more difficult to see it on the graph. Okay, so maybe what might be easy, that would give us a little bit more space, is that we could add 1.5 and subtract 1.5. So again, if you need help doing that, right, when we're adding 1.5